Greetings. This is Charles Darwin, and I'm down by the river again, and this time I'm in a population of sunflowers. It's in the middle of summer, and boy, this water tastes good. Anyway, what I'm here to talk to you about, obviously, is our categorical bias. Okay, let me explain. There are two kinds of people. Those who put people into two categories, and those who don't. Okay, let's think about that. Humans have a categorical bias. We like to take continuous variation, which is what we usually see in nature, and put it into discrete categories. We take continuous variables and turn them into discrete variables. The extreme form of that is the binary bias, where we just have two categories. For instance, as I said, putting people into two categories. This is especially common in religion. For example, in some religions, such as the Christian religion, there's a lot of variation in the way people live their lives. There's a lot of different beliefs that people have. There's a lot of different things that they do during their lives. But in the end, it all boils down to just two categories. Either you're in the sheep or you're in the goats. Either you're right or you're wrong. You're either going to heaven or you're going to hell. And all of that variation doesn't matter because it's subsumed into two categories. Or, if you want to think about more than one category, there's human races. We think of human races as being three races, maybe four. But if you look more closely, you find there's a lot of continuous variation within each of these races. They're not absolutely arbitrary races, but there is variation within them. For instance, we talk about the African race, but the people in Ethiopia are different from the ones in Nigeria, which are different from the ones in South Africa. There's at least three different races, and probably more, within the race that we generally call black. So there's a lot of variation, but we tend to categorize things. This is one of the biases we have to watch out for when we're doing scientific research. And of course, all humans do this, including scientists. No two plants in this population are alike. They may all look alike. They may all look like just common sunflowers, but each one of them is genetically different. Each one of these is as genetically different from the other as humans are from one another. This is even true of water molecules. No two water molecules in this container are exactly the same. Now, before it melted, there were some ice molecules. And of course, that was different from the liquid water molecules. But even within the liquid water molecules, no two molecules are the same in terms of their kinetic energy. Each one of them has its own kinetic energy. A broad average of that energy you can think of as the temperature, but each of the molecules has its own kinetic energy. Science tries to take what we categorize and turn it into continuous variables. So for instance, in many scientific studies, instead of having color, what you have is wavelength of light from 400 to 700 nanometers in the visible spectrum, instead of categorizing it into colors. Well, the point I'm trying to make is that there is diversity all around us, and that we should appreciate this, at least recognize it. This is Charles Darwin, tally ho, and amen.